The silence of space is broken not by sound, but by the weight of its own secrets. In the darkness beyond Neptune, a faint glimmer of light appeared. An object so small and so dim that only the most sensitive instruments could detect it. It was the year when humanity's telescopes had grown sharp enough to pierce the veil of infinity. And yet even they hesitated before the enigma. The object would later be named 3I Atlas, the third known interstellar wanderer to cross into the solar system. But in this first encounter, it was simply a stranger, an intruder at the gates of the sun. The light was fragile, like the spark of a dying ember drifting across a vast ocean. Astronomers saw only data points scattered across their screens, coordinates, magnitudes, the cold mathematics of celestial detection. Yet behind those numbers lay a truth more profound. The universe was not sealed, and the void was not empty. Something had come here from another star. The arrival of 3I Atlas carried an emotional gravity no equation could capture. Humanity had only recently witnessed the passage of 1I Oumuamua, with its unnerving acceleration and a shape too elongated to resemble any known comet. Then came 2I Borisov, a comet-like visitor carrying the unmistakable signs of interstellar chemistry. To encounter yet another intruder so soon was to feel the veil of cosmic isolation thinning. No longer could Earth imagine itself a lonely rock adrift in an indifferent void. The universe was beginning to speak, and each object was a syllable in a language we did not yet know how to read. For NASA scientists, the discovery was electrifying, but also unsettling. Every interstellar visitor carried the potential to reshape our understanding of cosmic origins. Was this shard of matter a fragment torn from a distant planetary system, cast adrift after some ancient cataclysm? Or was it something more enigmatic, a messenger born of processes humanity had never witnessed? The distinction was not trivial. A rock ejected by chance was one thing, a pattern of repeated arrivals was another. A hint that the universe might be far more crowded with fragments, relics, or even devices than we had expected. Telescopes tracked the object with precision, calculating its velocity and its path. Almost instantly, the numbers revealed an extraordinary truth. This was not a comet bound by the sun's gravity, nor a mere asteroid tracing the paths of planets. Its trajectory was hyperbolic, stretched beyond the grasp of the solar system. Its past lay among alien stars, and its future would carry it back to the galactic deep. It was a traveler that would not stay. And then came the quiet fear. If an object could slip so easily into the solar system, how many others had passed unnoticed in centuries before telescopes existed? What if Earth had already been brushed by fragments, or worse, struck by them? The thought gnawed at researchers in hidden ways. Catastrophes often come without warning. Here was proof that the universe could send visitors from unseen regions without a moment's notice. The question of impact was no longer theoretical. Every planetary collision recorded in craters on Earth or scars on the Moon was a reminder that the cosmos had teeth. But there was another fear. Deeper, quieter, harder to voice. Some scientists wondered if 3I Atlas, like Oumuamua before it, might not be entirely natural. Its brightness fluctuated in irregular rhythms, as though sunlight reflected from surfaces not entirely random. Its path, though gravitational, hinted at subtleties that raised eyebrows. NASA teams chose their words carefully, avoiding premature speculation. But whispers still moved through the scientific community. What if these visitors were not merely geological, but technological? What if interstellar space carried artifacts, probes, or relics of civilizations we have never met? Philosophically, the intrusion was overwhelming. To see something born in a different star system was to look at time itself, carried across light years, like a message in a cosmic bottle. The atoms composing it had once belonged to another sun, another nursery of worlds. Perhaps they had orbited a star that had long since died. Perhaps they had witnessed a civilization rise and fall, their fragments ejected by the violence of collapsing orbits. Every pebble in interstellar space is a history book, but the language is written in forces we are still learning to decipher. And so, 3I Atlas entered human awareness as more than a point of light. It became a symbol of intrusion, a reminder that the solar system was never a closed sanctuary. NASA's scientists looked upward with both excitement and unease, knowing the universe does not deliver such mysteries without consequence. Each interstellar object was a challenge to physics, to philosophy, and to humanity's fragile sense of solitude. This was no longer the era of distant speculation about whether we were alone. The era of visitors had begun, and the arrival of 3I Atlas, faint but undeniable, marked the first chapter of a new story, one that blurs the line between discovery and dread, wonder and fear. The faint light that betrayed the existence of 3I Atlas was first caught by the Asteroid Terrestrial Impact Last Alert System. A network of telescopes, its very name carrying the weight of cosmic vigilance, was built to guard Earth from unseen threats. Atlas became humanity's watchtower in the night sky, scanning the heavens for sudden flashes of danger. It was never meant to uncover interstellar riddles, yet in its nightly sweep across the stars, it caught a faint flicker, one that would grow into one of the most baffling discoveries of modern astronomy. The date was marked with clinical precision in observatory logs, but for the scientists on duty, the moment was electric. The thrill of finding what was never expected. At first glance, it was just another dim, moving speck, one more entry among thousands of catalogued asteroids. But its speed raised questions. With every new measurement, the truth became harder to ignore. This was no ordinary object. Its path across the sky hinted at a velocity the sun's gravity could not explain. Throughout history, such revelations have been born wrapped in confusion. When Galileo first turned his telescope to the heavens, he too saw things that defied accepted wisdom. Moons circling Jupiter, blemishes on the sun, the shifting phases of Venus. The discovery of 3I Atlas followed that same tradition, the sky revealing that reality was stranger than human theory dared to imagine. The astronomers who first plotted its course worked deep into the night, their calculations revealing a path unlike any asteroid bound to the sun. This was not a closed orbit like the planets. Its curve was open, a hyperbolic trajectory, a mathematical signature declaring it was born beyond the solar system. This was not a child of the sun, but a traveler hurled across the void by the gravity of a distant star. Its birthplace was buried in distances almost beyond comprehension. For NASA scientists, confirmation struck like lightning. Interstellar objects had long been theory, discussed in lectures, rendered in simulations, but never seen. The arrival of Oumuamua in 2017 cracked the door open, proving such wanderers could breach our cosmic borders. Borisov's appearance in 2019 threw that door wide, displaying all the hallmarks of a comet, yet with chemistry unknown to local space. Now with 3I Atlas, the door was not merely open, it was swinging wide. 3 intruders in less than a decade raised questions far larger than any one object could answer, and there was a quiet irony in its discovery. Atlas was built as an early warning system, a guardian against planetary catastrophe. Instead, it had stumbled onto something that inspired a very different kind of unease. Not fear of impact, but fear of meaning. If such objects were this common, then the galaxy teemed with wandering fragments. What tales did they carry? What chaos? What collisions had ejected them into the interstellar dark? And how many had slipped past before, unseen, while humanity's gaze was too dim to catch them? In the days that followed, observatories worldwide turned their eyes toward the intruder. Pan-STARRS, the European Southern Observatory, even amateur astronomers with backyard telescopes, all contributed their observations. The data poured in, orbital models refined with every additional speck of light. Science moved as it always had, curiosity binding minds together, collaboration turning mystery into understanding. There is always a first night, a first sighting, a first person to notice the speck that breaks the silence of the unknown. The astronomers who first recognized 3I Atlas were not merely plotting a rock, they were tracing the outline of a messenger from another world. Each pixel of data was a whisper, from a journey that began light years away, shaped by forces that predated Earth itself. For a fleeting moment, science touched poetry. To witness 3I Atlas was to see across time, to hold in sight a relic from a story written far from the sun's reach. Like an arrow loosed from an unseen bow, it had crossed gulfs of darkness to pierce human awareness. The astronomers may have spoken in numbers, but the tone was reverence, and something close to fear. Because this discovery proved that the solar system was not a sealed chamber, but merely a chapter. One page in a far greater epic now opening before humanity's eyes. And as new data poured in, its path became ever clearer. The numbers told a story both breathtaking and unsettling. Its orbit was not bound. It would never return. 3I Atlas was a true interstellar wanderer, a brief visitor from the infinite, passing through, never to be seen again. This was not a comet bound to the sun's embrace, nor an asteroid held by its familiar pull. Its journey was one way, into the solar system, and then back out again, a fleeting visitor from the deep darkness between the stars. To trace the path of such an intruder is to strip away layers of cosmic history. Orbital mechanics does not lie. The arc of its motion carried the fingerprints of its origin. Calculations revealed that 3I Atlas had approached from just beyond the constellation Lyra, its velocity clocked at tens of kilometers per second, far too great for any solar orbit to produce. It had been hurled from elsewhere, accelerated across the void by the gravitational violence of a system not our own. For scientists at NASA's Jet Propulsion Laboratory, the implications were staggering. This was matter born under a different sun, perhaps once part of a planet, forged in another cradle of creation and torn free by forces we can only imagine. Astronomers turned to precedent. Oumuamua, the first interstellar object ever found, had traced a similar hyperbolic path, skimming past Earth at a speed that defied comfort. In 2019 came Borisov, which displayed the classic beauty of a comet but with alien chemistry, its isotopic signature unlike anything local space had ever shown. And now, 3I Atlas stood in their company, its trajectory confirming what the galaxy had been hinting all along. The cosmos was not still, but alive with motion, scattering fragments of its architecture across gulfs of space. This repetition was no comfort. 3 visitors, in only a handful of years, had breached the solar system, each carrying its own strange and disquieting details. NASA scientists often say orbital calculations are a dialogue with the universe. Each refinement narrows the mystery, turning chaos into clarity. But this dialogue carried a shadow of unease. The hyperbolic orbit was steep, far too open to belong to any local asteroid. Its course implied staggering distances traveled, eons of wandering through the galactic dark. And yet, it shone with a brightness too fresh, too intact for something that had endured cosmic rays for millions of years. It gleamed as though it had not been weathered as much as it should have been. Astrophysicists asked, from what kind of system could this fragment have been born? Perhaps it was thrown outward from a violent planetary nursery, its exile forced as young giant worlds flung smaller bodies into interstellar space. Or maybe it was the result of some catastrophic stellar death, a supernova, a gravitational upheaval that shattered worlds and cast their bones into the void. Whatever its birthplace, 3I Atlas was a survivor, a relic carrying scars from a forgotten drama written under a foreign sun. The trajectory raised practical concerns as well. Interstellar objects do not linger. By the time its hyperbolic nature was confirmed, the intruder was already fleeing. Telescopes had only a brief window to collect light curves, spectra, and velocity refinements before it would vanish beyond reach. The urgency was intense. Every night mattered. Every observation a race against time. And for the astronomers tracing its path, the work carried a quiet emotional weight. To follow its orbit backward was to imagine the unimaginable distances it had crossed. Somewhere, in the far-off direction of Lyra, lay its true birthplace, now forever obscured by eons of galactic drift, blurred by the gravitational hands of passing stars. Plotting its course was to confront a humbling truth. The solar system is not sealed. Its boundaries are open gates, and through them, visitors can arrive unannounced, carrying with them mysteries older than Earth itself. As NASA scientists traced its path, they felt the tension between what was known and what was not. The mathematics was precise, the orbit hyperbolic, the speed undeniable, the origin interstellar. But the deeper question, the why of its journey, remained shrouded. Each answer spawned new questions, each calculation pointing toward unsettling possibilities. Thus, the act of mapping its path became more than mathematics. It became a moment of reckoning. Humanity, once again, was reminded that the familiar sky is not a closed dome, but a crossroads, a place where messengers from deep time can appear without warning. The universe was not silent. It was speaking, sending emissaries across the void, each whispering truths that shake both physics and philosophy. And as scientists often do, they turned to comparison, to the other wanderers that had already come before. Oumuamua and Borisov had written the opening chapters of this new field of astronomy. 3I Atlas was the next verse, and perhaps not the last. By placing 3 I Atlas alongside its predecessors, scientists searched for context, for pattern, and perhaps for meaning. Oumuamua, discovered in 2017, was the herald, its Hawaiian name meaning a messenger from afar arriving first. The title was fitting. Unlike any comet or asteroid ever seen, it appeared strangely elongated, perhaps cigar-like, or maybe as flat as a cosmic pancake. But its most haunting feature was its departure. Oumuamua accelerated in a way that gravity alone could not explain. Ordinary comets gain such speed through outgassing, jets of vapor acting like tiny thrusters. Yet Oumuamua released no plume, no dust, no visible gas. Nothing that could account for its strange push. The debate still smolders. Was it made of exotic hydrogen ice that sublimated invisibly? A bizarre fractal shard of carbon-rich dust? Or, as some daring voices suggested, could it have been a probe, an artifact designed by intelligence unknown? Then came Borisov in 2019, catalogued as 2I. Unlike Oumuamua, it looked instantly familiar, a textbook comet with a glowing coma and a trailing tail. But its chemistry was not local. Its gases bore the fingerprint of birth under alien conditions, enriched with carbon monoxide in amounts that shocked planetary scientists. It was proof that comets form around distant suns, proof that their processes mirror ours, though with striking differences. Borisov was both comforting and disquieting, a reassurance that the galaxy was familiar, but still deeply foreign. Against this backdrop came 3I Atlas, pressing urgently on the question of pattern. Was Oumuamua a one-time oddity, Borisov a more typical emissary, or was Atlas the middle ground between them? A sign that such objects are far more common than once believed. If 3 interstellar visitors could be discovered within a single decade, then perhaps the galaxy is teeming with wanderers, fragments born from the collisions and cataclysms that shape planetary systems. NASA's researchers framed Atlas within this narrative. It shared Oumuamua's faintness and ambiguity of shape, its refusal to be neatly classified, and it shared Borisov's role as confirmation, proof that interstellar visitors are not once-in-a-century events, but phenomena unfolding in real time, in the lifetimes of living scientists. Together, the 3 painted a portrait of diversity. There was no single class of interstellar object, but a spectrum, each carrying its own signature of origin. And with that diversity came unease. If interstellar debris could take so many shapes, then the possibilities stretched beyond the natural. Oumuamua's unexplained acceleration cast a long shadow, and Atlas rekindled those fears. Were these truly random fragments? Or were some of them instruments, scouts, or relics left behind by civilizations long vanished? The speculation was uncomfortable, but it refused to fade. Harvard astronomer Avi Loeb's suggestion that Oumuamua might have been technological still echoed through conferences and papers. And now, 3I Atlas arrived like a ghost of that argument, a reminder that dismissing the extraordinary too quickly could be dangerous. But the comparison was not just intellectual, it was emotional. For millennia, humanity believed the night sky was serene and eternal, its stars unmoving except for wandering planets and the rare comet. That illusion is now shattered. The solar system is not a walled sanctuary. It is an intersection on a galactic highway with traffic flowing unseen for ages. Oumuamua, Borisov, and now Atlas were simply the first travelers we noticed. How many others passed by in centuries before telescopes existed? How many left no trace at all? Each discovery shifted perception. Oumuamua filled humanity with awe, tinged with suspicion. Borisov reassured us that alien chemistry could be studied directly, without ever leaving home. And 3I Atlas tied both threads together, the suspicion of strangeness and the assurance of abundance. These were not mere curiosities. They marked the birth of a new science, a discipline that could be called interstellar archaeology, the study of relics cast across the galaxy. But this was no comforting thought. If such visitors were this common, then the solar system was far less isolated than we once imagined. Its boundaries were porous, and every new arrival carried not only scientific promise, but an undercurrent of existential unease. The comparison with its predecessors was a reminder. The universe is restless. Earth is no fortress. It is a fragile outpost adrift in a sea filled with messengers, each carrying stories we are only beginning to decipher. From the moment of discovery, 3I Atlas carried a riddle that unsettled the tidy framework of celestial mechanics. Its motion was not entirely obedient to the dictates of gravity. Astronomers expected a smooth arc shaped by the sun's pull, as with every comet and asteroid before it. Yet, when the data was refined, subtle deviations emerged. Accelerations too faint to dismiss as noise, yet too consistent to ignore. These shifts mirrored, almost eerily, the strange defiance of Oumuamua, as if it too shrugged off the sun's pull, driven by some unseen hand. At first, scientists searched for comfort in the familiar. Comets, after all, change speed as they warm, their jets of vapor firing like natural thrusters. But telescopes scanning 3I Atlas revealed nothing of the sort. No coma bloomed around it. No glowing tail followed its path. Its silence was damning. An object that behaved like a comet, yet refused to wear a comet's crown. Celestial categories blurred, and uncertainty spread like ripples across the data. The mystery deepened when brightness curves were examined. Sunlight striking its surface produced reflections that danced in patterns resisting easy interpretation. Instead of the steady beat one expects from a simple rotating body, 3I Atlas flickered unevenly, flashes and shadows chasing one another as if the object was twisting on an irregular axis. Some models painted it as a fractured shard, jagged, tumbling, chaotic. Others imagined a paper-thin pancake-like shape flashing when angled just right, vanishing when edge-on. Each model carried the same unsettling implication. Perhaps its very geometry was steering it, catching sunlight like a sail and bending its path. Non-gravitational acceleration is one of astronomy's most uncomfortable puzzles, because it hints at forces beyond mere gravity. Could sunlight's gentle pressure alone explain such motion? Calculations said yes, but only if 3I Atlas were astonishingly light, no thicker than a cosmic sheet, a design more expected from technology than nature. The line between natural shard and engineered artifact grew razor thin, forcing NASA scientists to weigh scenarios that bordered on science fiction. Worse, its path through space hinted at precision. Interstellar objects are expected to wander aimlessly, their trajectories the product of chaos. Yet 3I Atlas glided through the solar system on a course unnervingly exact, its intersection with Earth's neighborhood almost too perfect. The odds of such timing gnawed at modelers, forcing them to confront the question of whether coincidence was truly enough. It wasn't the size of the anomaly that troubled researchers, but its persistence. Every attempt to force the data to fit cometary models bent the equations to their breaking point. The object's refusal to behave was its defining trait. And as Oumuamua had done years before, 3I Atlas rekindled that same unease. Perhaps the universe was telling a story far stranger than we are ready to hear. Inside JPL, conversations turned quiet, deliberate. No one dared to label the object unnatural without proof, but the comparison to its predecessors could not be escaped. 3 interstellar visitors in under a decade, 2 of them defying gravity's script, was too sharp a pattern to ignore. To the public, these subtleties hid inside orbital reports and sterile data tables. But within the scientific halls, a whisper began to grow. 3I Atlas was mocking the very act of classification. A comet that was not a comet, an asteroid that refused to obey gravity's pull, a messenger that carried its secrets deliberately. Its mystery became more than a question of mathematics. It became a mirror, one reflecting humanity's fragile assumptions about order and stability. The solar system, once thought predictable and secure, revealed itself as porous, strange, open to the wanderers of the galaxy. 3I Atlas gliding across the night sky was a reminder that our cosmic neighborhood is alive, and its rules may be far from complete. Light is the oldest messenger of the cosmos. Every photon whispers across unimaginable distances, carrying the only truth we have of the far away. For 3I Atlas, light was the only clue. The faint sunlight it reflected was our sole connection to its nature. Yet that light deceived as much as it revealed. It did not settle into clarity, but instead painted a riddle of contradictions. Its first measurements suggested an ordinary visitor, faint and fleeting, slipping through the solar system. But as the nights passed, its brightness refused to obey expectations. Comets flare predictably, their icy skins igniting into halos as they near the sun. Asteroids shine with a steady rhythm as they spin. 3I Atlas fit neither pattern. Its light pulsed unpredictably, sometimes flashing brilliant, sometimes vanishing into shadow. A beacon that seemed to speak, but in a language no one yet understood. Models were crafted to explain the strange rhythm. Perhaps it was tumbling wildly, an irregular shard spinning like a broken blade adrift in the void. Perhaps its surface was mirror smooth, catching sunlight in sudden, dazzling flashes as though deliberately turning toward Earth. Some even suggested it was not a single body at all, but a loose cluster of fragments drifting together, their collective light waxing and waning as they rotated in a slow, chaotic dance. None of these answers felt complete. Each required assumptions about shape and material far outside what nature usually creates. When astronomers split its light into spectra, searching for chemical clues, they expected the familiar signatures: water vapor, carbon, silicates, the stuff of comets and asteroids. Instead, the readings came back thin, muted, as though the object's surface refused to speak plainly. It was as if it were cloaked, either by some strange material or a geometry that deflected a clear reading. In the language of light, 3I Atlas whispered just enough to provoke curiosity, but never enough to satisfy it. This game of brightness echoed the earlier riddle of Oumuamua, whose reflections had baffled even Hubble. At times metallic, at times dusty, its colors had shifted like a trickster. 3I Atlas followed that tradition of ambiguity, and the burden weighed heavily on NASA scientists interpreting the data. In astronomy, light is supposed to be law, the one truth teller across the cosmos. But here, even that law felt broken. At moments, the brightness hinted at deliberate geometry, as if flat panels or reflective sails were catching sunlight with purpose. Some whispered of radiation sails, structures designed to ride the gentle push of starlight. Others warned against jumping to conclusions, reminding colleagues that even natural shards can sometimes mimic intention. Still, the suspicion lingered. Perhaps this deception was not accidental. The public, reading headlines, imagined telescopes snapping photographs of alien ships. But in truth, 3I Atlas was nothing more than shifting numbers on a screen, points of light rendered from photons. The instruments were not lying. The object itself was. For astronomers used to pulling certainty out of faint cosmic whispers, this was unsettling at the deepest level. The fear beneath the equations was philosophical. Light is supposed to tell the truth. It carries history across light years faithfully. If even light deceives, then the universe is not just mysterious, it is deliberately withholding. And so, as scientists watched 3I Atlas, they faced the possibility that some cosmic stories are not meant to be read easily. Some visitors may arrive cloaked in riddles, their surfaces crafted, by nature or something else, to mislead. Within NASA's halls, debates stretched long into the night. Was the strange brightness a sign of a tumbling shard or a design meant to deceive? Both possibilities carried weight, and both carried consequences far beyond astronomy. If nature could create such tricks, then the universe was far stranger than imagined. And if it was the work of intelligence, then humanity had already entered a dialogue it did not yet know how to answer. Thus, the light of 3I Atlas became more than illumination. It became a veil, a shimmering curtain of half-truths daring scientists to look closer, question harder, and accept that even the oldest messenger in the cosmos can lie. As telescopes continued their vigil, one question burned brighter than all others. Where had it come from? To know its origin was to anchor its meaning, but every attempt to trace its birthplace only expanded the horizon of doubt. Trajectory analysis pointed toward a region near Lyra, but that offered only direction, not a home. Across interstellar distances, paths blur under the tug of passing stars, galactic tides, and invisible winds. By the time such a wanderer reaches us, its trail is ancient, its true birth shrouded in uncertainty. Some argued it was simply the product of violent scattering. Young planetary systems are chaotic, giant worlds hurling smaller bodies outward in a cosmic slingshot. Most of those fragments drift forever, becoming interstellar debris. If 3I Atlas was such a shard, it was the echo of a planetary system's birth, a splinter from a nursery now far away. Yet even that did not quiet the unease. Its strange brightness and motion hinted at something more than random exile. Others considered stellar catastrophe. Perhaps a planet had been shattered in the death throes of its parent star, its remains flung across the galaxy. Supernovae are known to scatter heavy elements, Why not the bones of worlds? If so, 3I Atlas might be the fossil of a destroyed planet, a relic of ancient cosmic violence. Such an idea carried a haunting poetry. To observe it was to stare at the remains of a place that no longer existed. But speculation did not end there. Some began to whisper of intention. If it truly behaved like a sail, perhaps it was designed to travel. Radiation pressure is faint, but eternal. A patient engine, a sheet launched long ago, could cross the stars given time. This was dangerous territory to tread, for it implied 3I Atlas was not merely from elsewhere, it was sent. NASA avoided public speculation, but behind closed doors the arguments grew fierce. 3 interstellar visitors in less than a decade. Was it luck or proof that the galaxy is teeming with wanderers, far more numerous than we had dared to imagine? If the galaxy truly teemed with such wanderers, then 3I Atlas was merely one voice in an endless chorus. But if its movement hinted at deliberate guidance, the meaning reached into places humanity was unprepared to face. Even time itself became a suspect. How old was this traveler? Had it drifted for millions of years before brushing past Earth's domain? Or had it been set in motion more recently, perhaps within the lifetime of civilizations now gone? Every answer carried its own gravity. If ancient, it was a fossil from deep time, carrying the memory of a forgotten era. If recent, it might point toward forces, or perhaps intelligences, that still operate in the galaxy today. The question struck at the heart of human perspective. If 3I Atlas was just a shard of rock or ice, its arrival still spoke to the restless nature of the cosmos, a reminder that the solar system is not closed, but open to visitors from the wider galaxy. Yet if it bore even the faintest mark of design, then humanity's home was no longer untouched, no longer truly isolated. In the end, its birthplace could not be fixed on any star map. The data twisted under too many uncertainties, pulled by too many gravitational hands across too many epochs. But this failure to locate its origin only deepened the unease. What cannot be traced cannot be fully explained, and what cannot be explained must be treated with caution. Thus, 3I Atlas remained an exile, a traveler without a known home. In its silence, it carried the implication that the galaxy was more alive, with fragments, relics, and perhaps intentions, than humans had ever dared imagine. The question of where it came from was left unresolved, but its journey had already stirred unease across NASA's halls. Velocity, after all, is more than speed. In astronomy, it is biography, the record of a life written in motion. How fast something moves tells the story of its birth, the forces that shaped it, and the distance it has crossed. And for 3I Atlas, the numbers were alarming from the very beginning. Its inbound velocity exceeded 30 kilometers relative to the Sun, a speed too great for any ordinary local orbit. Worse still was its excess speed, motion that no gravitational slingshot within our system could explain. It carried the unmistakable sign of an origin far from home, raising the question, what had launched it with such force? Planetary scattering seemed the simplest explanation. In the youth of star systems, giant planets often shift their orbits, flinging smaller bodies into interstellar space. Millions are thrown out this way, condemned to eternal wandering. But when the models were tested against the speed of 3I Atlas, the result was unsettling. Its velocity was simply too high. Even the most violent planetary ejections tend to bleed off energy through countless encounters. This object was too fast, as if hurled outward by something beyond the usual gravitational dance. Some suggested a dying star as the culprit, a sun collapsing into a white dwarf or neutron star, its planets ripped apart, their fragments flung outward like shrapnel. Such cataclysms can grant tremendous speeds, enough to explain this interstellar missile. If true, then 3I Atlas was not just a rock, but the survivor of a stellar death, a fragment carrying its velocity like a ghostly memory across light years. Others turned to stranger ideas. Could it have been nudged by dark matter, accelerated in some hidden region where unseen mass tugged more violently than expected? Or had it been pushed by starlight itself, slowly driven to its incredible speed over eons, like a seed blown by a cosmic wind? Here the line between accident and intent blurred. For though radiation pressure can move debris, it can also move sails, structures built with purpose. The thought hung in the air, unspoken but undeniable. Perhaps velocity itself was a clue not of chance, but of design. Its direction only made the mystery deeper. When traced backward, its path did not intersect any known stellar nursery, any obvious point of origin. It seemed to come from nowhere, its route too clean, too precise for something that had simply drifted through galactic chaos. Random debris should carry the scars of countless gravitational scars, small deflections magnified across time. Instead, 3I Atlas cut across the void with unnerving precision, as if placed on its course. For the scientists at NASA, its speed raised more than technical puzzles. It raised existential ones. If the galaxy truly brims with objects at such velocities, then Earth's position is more fragile than imagined. A collision with such a wanderer might be rare, but its energy would eclipse any local disaster. And beyond the danger lay a deeper fear, that its motion might not be random at all. Objects do not move this way by accident. If it was launched by physics, by catastrophe, or by intention, then its speed was more than a number. It was a message. For centuries, humanity has measured its place in the cosmos through motion. Planets orbiting stars, stars drifting through the sky. Speed was a sign of order, a way to predict the future. But here was an object that defied prediction, carrying with it a hint of violence, perhaps of purpose. In its relentless rush, scientists glimpsed both the fury of creation and the possibility of intent. Thus, the velocity of 3I Atlas was no longer a mere entry in an orbital report. It had become a story, a warning, and perhaps an invitation. It was a scar across the map of cosmic knowledge, a reminder that velocity was not merely a measurement, but a narrative. And this was a narrative humanity had not yet learned to decipher. As the data on 3I Atlas grew, astronomers shifted their attention toward its form and its surface, the very clues most elusive, yet most telling of its nature. Every interstellar object carries a geometry that speaks of its past, of collisions, of erosion, and perhaps, in the more daring corners of speculation, of construction. For 3I Atlas, the signals painted a portrait that was neither simple nor reassuring. Its light curve, those tiny pulses of brightness as it turned, pointed to something irregular, perhaps jagged. Unlike the mostly round asteroids of the main belt, or the smoother ice-bound comets, this traveler appeared unbalanced, tumbling chaotically. Some models rendered it as a long shard, a splinter torn from a larger body ages ago. Others envisioned it flattened, disc-like, flashing briefly as it caught and lost sunlight. Still others imagined a loose swarm of fragments bound together, drifting as one but reflecting light unevenly. None of these images felt final, yet each carried unsettling weight. Comparisons to Oumuamua only deepened the riddle. That earlier visitor had also defied every category, strangely elongated, strangely smooth, strangely spinning. 3I Atlas seemed to echo those qualities, but not closely enough to group them neatly together. Was it coincidence that two interstellar guests in less than a decade shared such improbable shapes? Or was some hidden process shaping them, one foreign to our solar system? Its surface made the mystery stranger still. The object was unusually dark, absorbing more sunlight than expected, a sign of carbon-rich material or long exposure to cosmic radiation. Yet its darkness was broken by sudden bright flashes, as though parts of its face were polished, metallic, or smoother than the rest. Spectroscopy offered no comfort. Some measurements hinted at ice, others at silicate rock, but the readings were muted, as though the surface wore a mask of something unknown. Perhaps an organic coating, tholins built over eons, could explain the darkness, but it could not explain the glints of light. The razor-edge sparkles hinting at something sharp, less weathered. For NASA's scientists, the combination was maddening. Nature makes irregular fragments, yes, but not often ones that appear to imitate design. A shard might be just a shard, but under the right conditions, it might also resemble a sail. A metallic flash might be mineral, or a hint of craft. In the quiet margins of technical papers, where speculation dared to breathe, the question persisted: was 3I Atlas only a geological relic, or a relic of intention? Even if natural, its shape hinted at a violent past. If it was fractured, it could have been born in a planetary collision, a fragment from a shattered world. If disc-like, perhaps it had been stretched thin by a tidal disruption, torn apart by the gravity of a passing giant. Each model spoke of cataclysm, of systems tearing themselves apart. To behold 3I Atlas was to behold a survivor, a scar set adrift in space, and philosophically, its surface became a mirror for the human mind. Some saw it as evidence of randomness, proof of a universe ruled by chance and violence. Others saw it as a whisper of purpose, a geometry too deliberate to dismiss, and between them lay the unknown, a surface that absorbed light yet threw it back in shards, daring astronomers to project their fears and hopes upon it. In conference halls, graphs and light curves became battlegrounds. Experts argued fiercely over whether its irregularity was within natural limits or outside them. Yet beneath all the numbers ran a quieter truth. 3I Atlas refused to reveal itself. Its form and its face, the most basic of clues, were both familiar and alien, plausible and impossible. It existed in tension with every category, as though crafted by a universe determined to keep certainty just out of reach. Thus 3I Atlas carried in its very body the essence of the enigma, a shape that refused to be pinned down, a surface that seemed built to provoke. At NASA, its geometry was no resolution, but a challenge. A reminder that even a stone, when it comes from beyond the stars, can shake the foundations of knowledge. Comets have always been humanity's most familiar visitors from the outer dark, icy travelers that flare into brilliance as they near the sun, their tails unfurling like banners across the night sky. For centuries, they carried both dread and wonder, omens to kings, marvels to poets. To modern science, they are no less fascinating, frozen archives of the early solar system. When the third interstellar visitor, 3I Atlas, was announced, many expected it to follow this familiar script. Surely it too would blaze with a tail, revealing its composition as it warmed. Yet what came next was not revelation but absence. The object refused to grow the classic coma. No fountain of sublimating gas, no plume of dust. Its very silence became its most troubling feature. The tail should have stretched across the void, a glowing banner declaring its cometary nature. Instead, silence. No coma appeared. No tail followed in its wake. Telescopes recorded only a stubborn point of light, flickering as though it held its breath, refusing to bloom into the ghostly plumes every comet wears. This refusal unsettled NASA's observers. A comet that refuses to be a comet shakes more than data. It shakes expectation itself, and expectation is the scaffolding of science. When it trembles, the entire structure seems to sway. Some sought ordinary answers. Perhaps it was nothing more than a fragment of ancient rock, its ice burned away by eons adrift in interstellar space. Perhaps cosmic rays had baked it long before it ever entered the solar system, leaving only a barren husk. Such an object could masquerade as a comet in origin, yet arrive empty, incapable of growing a tail. And yet, why did its brightness pulse and flicker, as if something restless moved across its surface? Others suggested hidden sublimation. Jets of gas could be firing from its crust. Too small, too brief to form a visible coma, but strong enough to nudge its path, explaining its mysterious acceleration. This explanation was one of the few that fit, and yet it too felt unsatisfying. No dust, no vapor, no scattering of light. Spectra showed no hint of outgassing, and still, the object moved as if pushed by unseen hands. The comparison to Borisov was damning. That second interstellar traveler had behaved by the book, its coma brilliant, its tail undeniable, its chemistry alien but logical. Borisov reassured scientists that the rules held true even beyond our sun. 3I Atlas shattered that comfort. It mocked the very categories we use to make sense of the sky. Not quite asteroid, not quite comet, but refusing to be either. In scientific papers, they used careful words, ambiguous, anomalous. In private discussions, the language was sharper, unnatural, designed, wrong. The absence of a tail became a presence of fear. If it was not a comet, what was it? A shard of planetary crust stripped of its ice, a relic of a shattered moon, or something stranger? A structure, thin and deliberate, built for the journey between stars. In astronomy, absence is often as revealing as presence. The missing tail was not emptiness, it was a message written in the silence of vapor that never came. Philosophically, this refusal weighed heavier than data could show. Humanity has always trusted categories: star, planet, moon, comet, asteroid. They are how we make the universe safe, placing chaos into labeled boxes. But 3i Atlas ripped open those boxes. It asked a question categories could not answer. What if there are things between? Things beyond? Things that do not care for our definitions? NASA's scientists logged the data, calibrated their instruments, and published their reports. But behind the technical language, the silence remained. This was not just a puzzle. It was a warning, a reminder that the universe does not promise to make sense, that visitors can arrive not just cloaked in strangeness, but in defiance of all we expect. And in that defiance grew a deeper fear. What if 3i Atlas was not here to be understood, but to remind us of how much we cannot? Its lack of a tail was unsettling, but its path carried a darker terror, the prospect of collision. When NASA plotted its trajectory, relief came with the confirmation. It would not strike Earth. Its hyperbolic path guaranteed escape, not impact. And yet, its sudden arrival, its immense speed, its unpredictable direction, forced scientists to face a brutal truth. What if the next one doesn't miss? The solar system bears witness to such events. The moon's pocked face is a graveyard of ancient collisions, each crater a silent testimony, untouched by wind or rain. On Earth, many of the scars are hidden, buried beneath oceans and forests. The Chicxulub crater in Mexico, the impact that ended the reign of the dinosaurs. The Tunguska blast of 1908, flattening forests with a force greater than the most powerful nuclear weapons ever built. These were local projectiles, stones and comets from our own neighborhood. What, then, of an interstellar body moving faster than anything bound to the sun? The energy of its impact defies imagination. NASA's calculations were chilling. A fragment, only a few hundred meters wide, traveling at the velocity of 3i Atlas, could release energy thousands of times greater than Earth's entire nuclear arsenal. Larger objects, kilometers across, could erase cities, continents, civilizations, perhaps even render Earth itself uninhabitable. The rarity of such events offered little comfort. Danger does not vanish because it is rare. It only waits longer to arrive. For NASA's planetary defense teams, this was no abstract thought experiment. Atlas, the very survey that spotted the object, was humanity's final sentinel. Its purpose, to give us days or weeks of warning should a killer rock be headed our way. But 3i Atlas had revealed the cracks in that shield. It had slipped into the solar system unseen, only noticed once it was already among us. How many others had come before, invisible in the dark? And if one day one comes on a direct path, how much warning will we truly have? There is a cruel poetry in such possibilities. Civilizations rise slowly, building knowledge, art, memory over thousands of years. Yet the cosmos, indifferent, holds the power to erase it all in a single, silent strike. The fear haunting NASA's halls was not only scientific, it was existential. It was the reminder that Earth, for all its beauty and history, floats defenseless in an endless dark. And beneath that fear lay another darker layer. If 3i Atlas was more than natural, if even a fraction of the whispers about design held truth, then the idea of collision was not just terrifying by chance, it was terrifying by intent. An interstellar probe striking Earth, by accident or by intention, would not simply scar the planet. It would be a message, carved into the crust, written in fire and extinction. The fear shifted, from mere chance to something darker, from statistics to confrontation, for now the path was merciful. 3i Atlas would glide past, a visitor, not an executioner. But that comfort was fragile, conditional, temporary. It relied on one assumption, that the next one would also miss, that the universe would keep sending messengers, not destroyers. And hidden in that assumption lay humanity's most dangerous weakness. A vulnerability no telescope, no defense system, no technology could erase. The specter of collision became the silent shadow in every discussion of 3i Atlas. It was the nightmare no one wanted to name, and yet it hovered over every orbital plot, every simulation, every projection. Each new interstellar visitor confirmed the same chilling truth. The solar system is not sealed, and the universe does not ask before sending stones across the sun's domain. The question was no longer if, but when. When will one of these travelers' paths no longer curve away, but aim for Earth itself? The fear of 3i Atlas was not just about what it was, but what it reminded us, that safety is an illusion. That civilization endures not by strength, but by luck, in a universe where chance rules everything. And 3 Atlas did not arrive in isolation. In less than a decade, astronomers had seen 3 interstellar visitors: Oumuamua, Borisov, and now Atlas. Before 2017, none had ever been confirmed. To see 3 in such rapid succession felt like the universe mocking coincidence itself. For NASA scientists, the repetition stirred a deeper, haunting possibility. Perhaps the galaxy is not a barren desert of wanderers, but a river, endlessly flowing with countless interstellar fragments, passing us all the time, unseen until now. The numbers were alarming. If 3 had been found in such a short time, statistics implied thousands more must cross the solar system every century. Most too faint, too small, too fast to ever be noticed. The solar system, once imagined as a quiet, isolated stage, now looked like a crowded intersection on a galactic highway. Every planet, every moon, even the sun itself, bathed in this silent traffic. This revelation shook the foundations of astronomy's quiet assumptions, and the timing raised new questions. Was this sudden clustering only because of better telescopes, more sensitive surveys, and relentless eyes like Atlas and Pan-STARRS? Or was something else at work? Some vast galactic alignment, funneling debris toward us right now, in this very era? If so, then humanity was living in a window of heightened exposure. A time when the stars seemed to be sending emissaries more often, and some dared to whisper an even more dangerous thought. What if these were not just stones? What if even one was a probe, a messenger built by someone? Then their arrivals, so close together, would not be coincidence. They would be coordination, a pattern, perhaps even surveillance. The thought was dangerous, but impossible to dismiss. Patterns always invite suspicion of purpose. NASA's official stance was careful, measured. This was the triumph of technology, not a sign of cosmic intent. Better instruments, not strange timing, explained the discoveries. And yet, behind closed doors, the unease lingered. For whether by chance or design, the pattern had already changed how humanity saw itself. Earth could no longer be imagined as a quiet outpost at the edge of the galaxy. It was now part of a larger web, a node in the silent network of the stars through which wanderers had passed unseen for centuries. Now they were seen. Now they could not be ignored. The weight of this truth was staggering. Humanity has always searched for meaning in patterns, constellations in the stars, rhythms in the seasons, cycles in the heavens. But to find a pattern in interstellar arrivals was to face a terrifying possibility: that the universe is speaking to us, whether by accident or by design. And this pattern, whatever it meant, carried no comfort at all. It spoke of intrusion, of fragility, of a universe far more crowded, more restless than the textbooks had ever promised. In this light, 3i Atlas was no longer a solitary object. It was part of a chorus, its voice rising to join those of Oumuamua and Borisov. Together, they sang of a living galaxy, a cosmos in motion, reminding us that the solar system's borders are not walls but open doors, and that Earth lies forever under a sky open to intrusion. And so the fear deepened. Not merely fear of what 3i Atlas was, but fear of what it represented. The possibility that this was not a lone visitor, but a harbinger of countless others, each carrying its own mystery, each carrying its own risk. In NASA's halls, this realization hardened into vigilance. If 3 had come, more would surely follow. And with every arrival, one question sharpened like a blade. What story is the galaxy trying to tell us? And are we ready to hear it? When the data refused to yield to ordinary explanation, some scientists turned to the edges of theory, where speculation meets the unknown. One of the most provocative ideas was this: perhaps the strange behavior of 3i Atlas was shaped by dark matter, the invisible framework of the cosmos. Dark matter does not shine, it does not scatter light, and yet it holds most of the mass of the universe. Galaxies spin on its unseen skeleton. Could it be that 3i Atlas carried whispers of this hidden architecture? The speculation began with its anomalies, the faint, unexplained accelerations, the erratic flickers of brightness, its refusal to fit into asteroid or comet categories. Perhaps it had drifted through a region dense with dark matter, its motion nudged by invisible currents. Tiny perturbations, imperceptible over light years, could accumulate into the deviations astronomers now observed. In this view, 3i Atlas was not just a messenger, but a vessel, carrying the fingerprints of unseen forces that thread the galaxy together. Some theorists pushed even further. If dark matter clumps into halos, filaments, or rivers, perhaps 3I Atlas had passed through one, and the scars of that encounter were written into its trajectory, its flickering light curve, its unsettling behavior. In this way, the object became an accidental probe, delivering clues about phenomena humanity has never directly touched. But the idea carried dread as well as wonder, for if interstellar objects are constantly shaped by such forces, then every visitor to the solar system is marked by a physics we do not yet understand. To study them is to stare into the invisible, and to admit just how blind we really are. NASA's physicists debated cautiously. Dark matter remains a hypothesis wrapped in mathematics, its presence seen only in how it bends galaxies and stars. To invoke it here was bold, even risky, but the anomalies demanded explanation. Better, perhaps, to entertain the invisible than to force the visible into unnatural boxes. The public never heard most of these whispers. Press releases spoke of unusual properties and difficult classification, but not of dark matter streams bending stones from other stars. And yet, within the scientific community, the idea was electric. What if every interstellar visitor was not just debris, but a test particle, tracing the hidden contours of the galactic web? To chart their paths might one day mean charting the very skeleton of the universe. The thought was humbling. Dark matter has always been the great ghost of cosmology, the invisible majority of existence. To imagine 3I Atlas marked by its hand was to face the terrifying possibility that the universe is more ghost than solid, more unseen than seen. Its anomalies became less about the object itself and more about the abyss of ignorance they exposed. And so, whispers of dark matter joined the growing chorus, none definitive, all unsettling. Perhaps it was just a shard of rock behaving strangely. Perhaps it was a relic of cosmic violence, or a probe, or something stranger still, or perhaps it was simply the first to reveal that the paths of the universe are written not just by stars and planets, but by the unseen matter that holds them all in place. And that was NASA's deeper fear, that reality itself is shaped by forces we cannot see, forces that steer every orbit, every visitor, every fragile calculation of safety. 3I Atlas was a riddle, yes, but also a reminder that the cosmos rests on foundations as hidden as they are vast. The most unnerving clues lay not in its shape or speed, but in the smallest deviations of its orbit, imperceptible to the eye, but undeniable in the mathematics. NASA's teams and observatories worldwide compared thousands of data points against the laws of Newton and Einstein. The predictions should have been perfect. Gravity leaves little room for ambiguity, and yet 3I Atlas refused to obey completely. The deviations were slight, fractions of a second, minute shifts of angle, but they were persistent. Each recalculation brought scientists closer to the truth they dreaded. The object was not moving exactly as gravity demanded. Non-gravitational forces were the obvious explanation, but the usual culprits, outgassing, jets, solar wind pressure, remained stubbornly absent. 3I Atlas was accelerating as though pushed by an invisible hand, one that left no trace. Some were reminded of the great puzzles of the Pioneer anomaly, when spacecraft once drifted mysteriously from their predicted paths, until the answer was finally traced to the faint warmth of their own engines. But here, there was no warmth to blame, only the silence of the void and the mystery of a visitor that refused to behave. But with 3I Atlas, there was no heat signature, no exhaust, no source to blame. The analogy to the Pioneer anomaly only deepened the unease. Those spacecraft had behaved strangely because they were built things with quirks and imperfections born of engineering. But if a natural object showed the same defiance, then what exactly was it? Alternative explanations began to feel strained. Some suggested uneven reflectivity, sunlight pushing harder on one side than the other. But for the numbers to work, the object's shape would need to be impossibly thin, almost like a cosmic sail. Others considered interactions with interplanetary dust or magnetic fields, but the forces were far too weak to account for what was observed. Every failed explanation closed one door, only to open a darker one. The gravitational anomalies were small, but they struck at the very core of scientific certainty. Gravity is the one law the universe has always obeyed. From the orbits of planets to the dance of galaxies, to see it questioned, even at the edges, was to feel the foundations of physics tremble. NASA's analysts grew cautious, almost superstitious, in how they described their findings. They spoke in careful language, of residuals, non-linearities and uncertainties, but beneath the jargon, the truth was clear. Something was pushing 3I Atlas, and no one knew what. Inside scientific circles, the anomaly became a quiet obsession. Could this be evidence of exotic physics, dark matter currents, quantum field effects, even hints that gravity itself might not be complete? Or was it something more deliberate? If a probe were designed to hide its propulsion, to mimic the motion of a natural body while carrying an unseen intent, would it not look exactly like this? Almost gravitational, but not quite. The thought was uncomfortable, but it lingered in every late-night discussion, shadowing every dataset. For the public, the anomaly remained invisible, buried in equations too dry to spark imagination. But for those inside NASA, for those who plotted the curves and watched them refuse to align, the fear was palpable. They were staring at a pattern that did not belong, a visitor that refused to bow fully to the oldest law in the universe. Its trajectory was precise, but deviated just enough to feel as though it were balanced on the knife's edge between the natural and the engineered. Philosophically, the implications were chilling. Humanity has always believed that nature is lawful, that the cosmos can be reduced to equations, but here was an object quietly defying those equations, a reminder that perhaps the universe still keeps secrets beyond the reach of mathematics. The deviation was not merely orbital, it was existential. And so, in the margins of official reports, in the hushed corridors of midnight conversation, 3I Atlas became a symbol of unease, not large enough to panic the world, but persistent enough to gnaw at confidence. It had entered the solar system as if to whisper, "Your laws are not complete, your certainties are fragile, your understanding is unfinished." The whisper that trailed behind it was not only of rock or ice or gravity, it was a whisper of design. Inside NASA, most resisted the word. They feared speculation that could erode credibility, and yet, the refusal of the object to conform, to be fully comet or fully asteroid, to obey gravity without leaving a trace of rebellion, invited the question no one wanted to voice aloud. What if it is not natural at all? Oumuamua had already cracked that door open. Its thin, tumbling shape, its unexplained acceleration, its lack of dust or vapor, all had led Avi Loeb and others to suggest it might be artificial. Dismissed by many as premature, the claim nevertheless lingered. And when 3I Atlas arrived with its own shroud of strangeness, that ghost of speculation returned. The parallels were impossible to ignore. Irregular light curves, mysterious accelerations, ambiguous chemistry. It was as though a pattern was forming, each new visitor part of the same cryptic message, each a riddle written in the same unsettling script. And in private rooms, the fear sharpened. A natural shard of rock is never frightening, no matter how strange its path. But a technological relic, drifting silently through interstellar space, that is something altogether different. Perhaps still functional, perhaps dormant. Its very existence carried implications that shattered the idea of human solitude. What if 3I Atlas were a probe, launched long ago by a civilization now distant or even extinct? What if it were designed to watch in silence, to gather data, to slip past unnoticed until the right eyes finally turned toward it? The thought itself shifted perspective. Its strange reflections suddenly looked like panels. Its trajectory felt less random, more intentional. Its silence on the radio bands became not emptiness, but refusal. For NASA, the weight of such an interpretation was almost unbearable. To suggest alien origin is to invite scrutiny, ridicule, and accusations of sensationalism. But to ignore the possibility risks blindness. The line between fear and curiosity grew perilously thin. History offered precedent for such unease. When pulsars were first discovered, their signals were so precise that their discoverers half-jokingly called them LGM, little green men. Only later did the natural explanation emerge. rotating neutron stars. Perhaps 3i Atlas would prove the same. Strange now, mundane later, but the lesson of the pulsars carried a warning. Not every pattern is natural. To leap too quickly toward comfort is to risk overlooking the extraordinary. And if 3i Atlas were artificial, the implications would ripple outward like shockwaves. Who had built it? When? And how many more were out there drifting unseen? Was Earth being watched? Or was our solar system simply one waypoint among millions? This was no longer just a question of science, but of philosophy, politics, even theology. Humanity has always looked to the stars and asked, are we alone? And here, perhaps, was an answer, drifting silently past, as though expected. Even if artificial, the possibilities divided like branches of a tree. It could be ancient wreckage, a dead shell. It could be a probe, functional but indifferent, recording without interference. Or it could be something far more deliberate. Surveillance, mapping, preparation. Its silence left every possibility open, each one more unsettling than the last. NASA's fear was not of proof. Proof could be confronted, debated, answered. Its fear was of ambiguity, the splinter that never leaves the mind. They could catalogue 3i Atlas, track its path, publish their data, but the suspicion that it might be a machine, not a stone, would remain, haunting them with every new faint object found in the sky. Philosophically, the fear deepened into reflection. Humanity had long assumed that contact, if it ever came, would be unmistakable. A signal, a ship, a landing. But perhaps the universe speaks more quietly. Perhaps contact arrives not as communication, but as presence. Artifacts drifting silently, indifferent to whether we recognize them. In that light, 3i Atlas was no longer just an anomaly. It was a question, and the question it asked was simple, terrifying, and unanswerable. What if they are already here, and have been for longer than we can imagine? The speculation surrounding 3i Atlas did not exist in isolation. It resonated with a movement already stirring in astronomy, the search for techno-signatures, not alien voices, but alien engineering. In the wake of Oumuamua's controversy, projects had emerged to test the possibility that interstellar visitors were not just rocks, but relics. Chief among them was the Galileo project, a bold initiative led by Avi Loeb, seeking to study both unidentified aerial phenomena and interstellar objects with scientific rigor. To many at NASA, the Galileo project was provocative, perhaps even dangerous. It walked a razor's edge between courageous science and forbidden speculation. Yet, the repeated arrival of interstellar objects gave it new weight. If Oumuamua had been dismissed too quickly, and if 3i Atlas carried echoes of the same mysteries, then perhaps a systematic search for alien relics was no longer reckless, but necessary. The fear was not merely of ridicule, but of being unprepared, of ignoring what might be the single most important discovery in human history. Techno-signature research reframed the conversation. No longer were scientists only waiting for alien civilizations to send radio beacons. Now, they considered artifacts, a drifting sail between stars, a fragment of an ancient machine, even pieces too eroded to function, all potential evidence of intelligence. In this framework, 3i Atlas became more than a puzzle of chemistry or trajectory. It became a test case, a candidate for artifact status. NASA had to move carefully. Publicly, it emphasized natural explanations in keeping with scientific conservatism. But quietly, its scientists collaborated with independent projects, pooling data, refining models, entertaining the possibility that something unnatural might be hiding in the steady stream of visitors. The line between open acknowledgement and whispered speculation grew razor thin. The echoes of history loomed large, just as Galileo's telescope had shattered complacency by revealing moons circling Jupiter. So too might these modern surveys shatter the illusion of human isolation. The Galileo project, named for that very man, was not merely an effort to gather data. It was an act of defiance, a challenge to cultural inertia, a refusal to look away from the extraordinary. In the light of 3i Atlas, its mission felt prophetic, and yet fear tempered the excitement. To admit the possibility of alien artifacts is to admit that Earth's sky may already be occupied, its neighborhood already surveyed. It reframes our world, no longer an untouched cradle of life, but one of billions of destinations, perhaps observed long before we could ever look back. For those who stared at that faint dot through their telescopes, the weight of that realization was almost unbearable. And as with Galileo centuries ago, the lesson was clear. Science is not only about data, but about courage. To call anomalies noise is safe. To call them messages is dangerous. But perhaps this is the only path to truth. The fear surrounding 3i Atlas was never just about what it might be, but about what it asked of us. It demanded courage. The courage to stare into the unknown without blinking, to think without retreat, to accept that perhaps the universe is already speaking, and we have simply been too afraid to listen. Within NASA's quiet halls, the shadow of Project Galileo began to stretch longer. What had once been dismissed as speculation now carried weight. Not because there was undeniable proof, but because the patterns kept repeating. One anomaly could be written off. Two might still be coincidence, but three, arriving in close succession, was a pattern, and patterns demand explanation. 3i Atlas, natural or not, had become a spark, a challenge. It reminded humanity that the universe does not reveal its secrets to those who hesitate, but to those willing to ask the questions we are told not to ask. And then, a quieter, more unsettling idea began to take shape. What if 3i Atlas was not a probe alive in the present, but a relic, a remnant, a piece of a civilization that once was? To think of it this way was to step into the field of cosmic archaeology, where every interstellar object becomes more than just a rock. It becomes a fragment of history. Civilizations rise and fall on Earth. Why not among the stars? If intelligent life has existed elsewhere in the galaxy, time guarantees that most of it is already gone. 1 billion years is enough to erase even the mightiest empire, scattering its creations into dust. Perhaps the silence we hear in the cosmos is not proof that we are alone, but the echo of extinction. And if so, then objects like 3i Atlas might be the fossils of a galactic past, tombstones of civilizations we will never know. This was not wild fantasy. Humanity itself has already seeded space with thousands of probes, satellites, and fragments of metal. 1 million years from now, when Earth itself may have gone silent, those remnants could still be drifting among the planets. Some might shatter, becoming indistinguishable from asteroids. Others might survive, their shapes eroded but still betraying a hint of design. To alien eyes, they would be mysteries, just as 3i Atlas is to us. Perhaps what we are seeing now is simply the mirror of our own future. Even if natural, 3i Atlas still carries memory within its atoms. It was born in a star far older than our own, sculpted in a system we may never see. Every interstellar visitor is a time capsule, whether shaped by nature or intelligence. And so, to view 3i Atlas as a relic was to face a different kind of fear. Not fear of invasion, not fear of surveillance, but fear of impermanence. The fear that intelligence always burns out, leaving behind only wreckage. Every visitor becomes a memento mori, a reminder written in orbits and trajectories. Civilizations die, their fragments keep drifting, and 3i Atlas, passing silently through the solar system, may be such a fragment, a mirror, showing not just where it came from, but where we too may one day go. When conventional explanations failed, theorists went even further. What if 3i Atlas was not even made of ordinary matter? What if it contained something exotic? A fragment of physics beyond the standard model, a splinter of some deeper reality. Some imagined it as a quantum mirror, an object that reflected not only light, but the hidden structure of the cosmos itself. Its strange flickers could be interference, as though two realities were overlapping. Its subtle accelerations could be nudges from fields that our equations do not yet describe, whispers from dimensions brushing against our own. Exotic matter has long been imagined as the stuff of interstellar drives and wormholes, the bones of impossible machines. If even a trace of such matter were present within 3i Atlas, it might be evidence of engineering beyond comprehension. NASA rarely spoke of such things aloud. These ideas lived in appendices, in quiet conference corners, in late-night conversations where fear and wonder merged. But the object's refusal to fully behave like a comet gave these whispers weight. Philosophically, the quantum mirror hypothesis struck at the deepest human suspicion that the reality we see is not all that exists. If 3i Atlas was such a shard, then the universe itself is not sealed. It leaks, and through that crack, we catch a glimpse of the hidden ocean beneath our known physics. This was not the fear of alien invasion. It was the fear of destabilization. The fear that our most cherished equations describe only the surface, while the true laws lie deeper, out of reach. Thus, in some interpretations, 3i Atlas became not just a rock or a relic, but a message from the underlying structure of reality itself. Its path seemed to whisper that even Einstein's great work was not the final chapter. Relativity could explain its general motion, yes, but not the little pushes, the strange brightening, the quiet defiance of prediction. It was as though 3i Atlas carried within it a correction, a term that Einstein never got to write. And perhaps, somewhere, he would have smiled at that. He never lived to see it completed. Decades later, Stephen Hawking would take up the same pursuit, trying to reconcile black holes with entropy, space-time with information. Each attempt pulled back another layer of the puzzle, yet the circle never fully closed. And now, as 3i Atlas crossed the night sky, its strange behavior seemed to press on that very unfinished gap, as if whispering, "Look closer. The laws you call absolute are only shadows of a deeper truth." Inside NASA, theorists confronted unsettling possibilities. Could the tiny deviations in Atlas's orbit hint at something more? A modification to gravity itself? Some speculated about MOND, modified Newtonian dynamics, theories that change how gravity behaves at the faintest accelerations. Others wondered if subtle interactions with the quantum vacuum could be pushing it, forces invisible yet undeniably real. Each idea strained the imagination, but all pointed to a haunting possibility: that the universe was not yet done surprising us, and that Einstein's equations were only the first verses of a much longer poem. The fear was not just scientific, it was philosophical. Relativity had given us confidence, the belief that the universe, though vast, was readable. To see cracks in that framework was to face cracks in the foundation of knowledge itself. If even Einstein's laws could not account for an object as small as 3i Atlas, what else lay out there in the dark, unaccounted for, unimagined? In the quiet of midnight discussions, scientists allowed themselves a dangerous thought. Maybe 3i Atlas was more than just an object. Maybe it was a test, a riddle placed in our path to push humanity toward the next frontier. Just as Mercury's strange orbit once led Einstein to relativity, perhaps these new anomalies were guiding us toward a theory that could finally unite gravity and the quantum world, revealing the hidden scaffolding of the universe. And yet, with each revelation, fear remained. Discovery is not always gentle. New laws do not always bring comfort. They can also bring fragility. They remind us that the universe may be far less stable than we imagine. If relativity is incomplete, then space-time itself is not eternal. It is evolving, and we are living inside a cosmos whose rules may still be changing. Thus, 3i Atlas became to some Einstein's shadow, an object casting doubt on the certainty of physics. A reminder that our greatest theories are temporary waypoints, and that every visitor from the stars might carry with it not just matter and momentum, but correction, forcing us to rewrite the story of reality itself. If Einstein's equations framed the mystery of Atlas, then Stephen Hawking's words gave it weight. Hawking had long warned against blind curiosity, against assuming that contact with alien intelligence would be safe. He often reminded the world that history is full of encounters between the powerful and the unprepared, and they rarely ended kindly. If interstellar visitors were not just stones, but artifacts, probes or messengers, then their silence was not necessarily reassuring. Silence could mean caution, or worse, indifference. Inside NASA, those echoes could not be ignored. Hawking's warnings about broadcasting our presence into the cosmos, about calling out into the dark before knowing who might be listening, loomed even larger as Atlas drifted silently past. Its refusal to behave like a simple comet or asteroid left space for speculation. What if it was listening? What if it was not a relic, but a scout? The lack of any detectable signal gave no comfort. Silence, after all, can be strategic. The unease deepened when scientists noticed the pattern. 3 interstellar visitors in only a handful of years. If this was mere coincidence, then the galaxy was far more crowded with wanderers than we had ever imagined. Some natural, perhaps, and some not. If it was not coincidence, if it was deliberate, then humanity might already be under observation. Our world catalogued, not by choice but by inevitability. Hawking's warnings began to sound prophetic. He said, "We may not want to meet those who find us." The fear was not of invasion, not fleets of ships and dramatic battles, but of something subtler: surveillance, patience, indifference. On a cosmic scale, a probe does not have to act to change history. Its mere existence changes everything, reframing humanity not as the observer, but as the observed. Even a dead probe, abandoned for millennia, would shatter our narrative of solitude. To find evidence of alien engineering, even without a signal, would rewrite every philosophy, every theology, every myth we have ever told about our place in the cosmos. Hawking's voice resonates because it forces us to face scale. Civilizations rise and fall in centuries, but a species capable of launching probes across interstellar distances might measure its history in millennia, perhaps millions of years. Their motives, if they still exist at all, would be beyond comprehension. Their technologies might be indistinguishable from the laws of nature themselves. To encounter even a fragment of such a civilization is to stare into a gulf so vast that human dreams and fears feel like the playthings of children. And yet, Hawking also embodied curiosity. For all his warnings, he never turned away from the unknown. He sought the edges of black holes, chased a theory of everything. His caution was never a call to retreat. It was a call to proceed with care. NASA's scientists felt that same tension as they studied 3I Atlas. To stay silent might be safe, but to look away would be to waste the rarest of opportunities. In its quiet passage, 3I Atlas forced humanity to confront the double-edged nature of discovery. Knowledge can expand our understanding, but it can also expose our fragility. The fear surrounding it was not only scientific, it was existential, echoing Hawking's warning. If the cosmos is alive with intelligence, then humanity is not the center of its story, only one observer among billions. And if probes have already arrived, then perhaps we are not observers at all. We are the observed. The unease that 3I Atlas inspired was never just about its speed, its shape, or its eerie silence. It reached deeper into the question of what role such wanderers might play in the larger story of planets and life itself. Could interstellar visitors like this be more than messengers? Could they be actors, agents shaping the fates of worlds, carrying the seeds of creation or extinction across time? The old idea of panspermia, life carried between stars on fragments of rock or ice, suddenly felt less like speculation and more like a quiet possibility. Microbes, buried deep within a body's crust, might endure the cold voyage between stars and awaken under the right conditions. If 3I Atlas was such a carrier, then its passage was not merely an astronomical event, but a biological one. Perhaps part of a hidden network of exchanges that has been shaping evolution on Earth and on countless other worlds for billions of years. Was it so absurd to imagine that the seeds of life here once rode in on an interstellar traveler, indistinguishable from Atlas itself? But shadowed beneath that thought was a darker possibility, that such objects might not just create life, but erase it. A high-velocity impact from beyond the solar system would strike with energy beyond anything local asteroids could deliver, resetting an entire biosphere, wiping out ecosystems in a single moment. In this vision, interstellar wanderers are both creators and destroyers, custodians of time, shaping destinies without intention or malice. 3I Atlas, gliding silently past, became a symbol of that duality. Bringer of life, or harbinger of extinction. NASA's planetary scientists approached the thought with caution. Official reports spoke of low probabilities, of mechanisms still uncertain, but the philosophical weight lingered. If objects like this have been visiting the solar system for billions of years, then Earth itself is the product of their passing. The story of life might not be a local tale at all, but a galactic one, written in collisions, in transfers of matter, in the slow weaving together of distant star systems into one shared biological experiment. It was an unsettling thought. If life can be seeded so easily, then perhaps it thrives everywhere, rising, dying, and spreading again in cycles older than humanity. But if extinction can also be delivered so easily, then life is fragile everywhere, always at the mercy of impacts from the dark. 3. I-Atlas embodied both possibilities at once: creation and erasure, promise and threat. Philosophically, this shifted the fear from technology to inevitability. Even if Atlas was natural, its existence reminded us that time is written not just in centuries and millennia, but in impacts and extinctions. Civilizations may rise and fall, but the deeper rhythm is planetary, the endless cycle of seeding and scouring, beginnings and endings delivered from the stars. To watch 3 I-Atlas pass harmlessly by was to feel relief, but also to know that relief was temporary. The cosmos plays a longer game, and humanity is only a recent participant. In this light, 3 I-Atlas was no mere curiosity, it was a mirror, showing Earth both its origin and its possible fate. Whether fragment of chaos or relic of intent, it carried the reminder that worlds are never isolated. They are nodes in a vast galactic network of collisions and exchanges. To live in such a universe is to accept fragility not as an accident, but as a law. Thus, the fear surrounding Atlas expanded into time itself. Not only could such visitors end civilizations, they may already have shaped them, long before any telescope could witness it. And in their silence, they remind us of a harder truth. The story of life is always provisional, always subject to the next visitor whose path crosses our own. In the corridors of NASA, a darker whisper emerged, one not just from astronomy, but from the heart of particle physics. The spectre of vacuum instability. For decades, physicists have debated whether our universe is truly stable, or whether it rests precariously in a false vacuum, a delicate, metastable state. If ever disturbed, such a vacuum could collapse to a lower energy state, rewriting the very laws of physics. If that day ever came, atoms would unravel, chemistry would dissolve, stars would go dark. It would not mark the end of life alone, but the end of reality itself. And how could such a nightmare connect to an interstellar wanderer like 3 I-Atlas? The thought was rarely spoken aloud, but it lingered like a shadow. Perhaps such objects are not innocent fragments at all. Perhaps they carry exotic matter, strange quarks, or particles stabilized under alien conditions. Seeds of instability traveling through the void. A collision with Earth, or even with another planet, might create the exact conditions needed to tip the universe into collapse, to trigger the fall of the false vacuum. The scenario bordered on nightmare, yet it was rooted in real mathematics, in equations that physicists cannot completely dismiss. This fear was not new. When the first great particle accelerators, like the Large Hadron Collider, were proposed, some warned that their high-energy collisions might spawn strangelets or microscopic black holes, capable of unraveling the fabric of space itself. Those fears proved unfounded, and yet, the thought experiment never truly died. 3. I-Atlas, with its defiance of expectations, rekindled that unease. What if it was more than rock? What if it carried the kind of exotic matter that could rewrite the stage upon which the cosmos itself is played? NASA's physicists never spoke this speculation in public. It was too destabilizing, too apocalyptic. But in private circles, the thought was raised. Its faint irregularities, its refusal to follow familiar rules, gave just enough room for such terrifying ideas to take root. If 3 I-Atlas could not be explained by known matter, then perhaps it carried unknown matter, and with it, unknown risks. The philosophical weight was staggering. Humanity has always imagined the universe as eternal, a fixed canvas upon which civilizations rise and fall. But what if the canvas itself is fragile? What if reality is contingent, balanced on a knife's edge, vulnerable to collapse? In that light, every interstellar visitor becomes not just a puzzle, but a reminder that existence itself is not guaranteed. And yet, within this dread, there was also wonder. If such exotic matter truly exists, and drifts through the galaxy in relics like 3 I-Atlas, then it offers not just risk but revelation, a glimpse beyond the standard model, a chance to peer into the hidden architecture of reality. In science, danger and discovery are twins. To touch the unknown is always to risk transformation. And so, 3 I-Atlas carried not only the fear of impact or the suspicion of alien technology, but the deeper dread that it might alter the very fabric of existence. Even in silence, Even as it passed harmlessly through the solar system, it forced humanity to confront the possibility that the laws of the universe are provisional, that they can be broken, rewritten, or erased. Every shard drifting between stars might be both messenger and executioner. And as 3I Atlas slipped deeper into study, a new thread of speculation emerged, one at once breathtaking and terrifying. What if this object was not merely matter at all? What if it was a messenger, not just between worlds, but between universes? The idea had once lived only in the most speculative corners of theoretical physics. Now, whispered in late-night discussions, it began to gain weight. What if 3I Atlas was a trace of the multiverse? The multiverse hypothesis suggests that our cosmos is not singular, but one of many, each with its own physical laws, its own constants, its own dimensions of space and time. If universes are born like bubbles in a cosmic sea, then sometimes those bubbles might collide, overlap, or leak. What if 3I Atlas was evidence of such a leak, a shard from another cosmos, wandering across the boundary of reality itself? Its strange brightness, its unexplained accelerations, its refusal to fit any known category, all began to look different in this light. Perhaps its very matter was tuned to alien constants, surviving here only as a ghost. Perhaps its smooth, improbable path was less an orbit and more a scar, a trace of passage between realms. NASA's physicists did not write such speculations into official reports. But the multiverse had already entered mainstream cosmology through the theory of eternal inflation, the idea that universes are forever budding into existence. If that is true, then interuniversal debris is not impossible. And if not impossible, then perhaps 3I Atlas was exactly that, a fragment from somewhere else, a messenger drifting across the threshold to remind us that even reality has borders. The philosophical impact was staggering. To imagine Atlas as a visitor from another universe was to dissolve the last barrier of human solitude. The cosmos would not only be vast in size, it would be vast in kind. Our laws of physics would no longer be universal truths, but provincial rules, applying only to this one bubble among many. In that view, 3I Atlas was less a rock and more a symbol, proof that existence is layered and that our universe is not alone. But such a possibility carried its own fear. If debris can cross from one universe into another, then the boundaries may not be as solid as we believe. If a shard can drift through, what of a torrent? What if universes can rupture, collide, or bleed into one another? A shard is wonder. A torrent would be catastrophe. In this light, 3I Atlas became both marvel and omen. For some, the thought was liberating. Humanity's search for meaning need not end in silence. For others, it was chilling. For if the multiverse is real, our place within it is even smaller than we imagined, our survival even more contingent. 3I Atlas became a doorway, glimpsed for an instant. A reminder that beyond our stars may lie not only other worlds, but other realities. And so the fear deepened. Was Atlas a rock, a probe, a relic, a shard of exotic matter, or a fragment of another universe entirely, drifting across the threshold like a message in a bottle from shores we cannot see? Whatever the truth, the question remained the same. How fragile is the barrier between what we know and what we cannot yet imagine? And then came a new speculation, one that reached into the heart of modern cosmology. Could 3I Atlas be linked, however faintly, to the mystery of cosmic acceleration, the phenomenon humanity calls dark energy? For decades, astronomers have known that the universe is not slowing down as gravity would suggest, but racing apart faster and faster, as if driven by an unseen force. Dark energy is the name we give to that force, but in truth, it is just a name for our ignorance. Might 3I Atlas, strange in its path, stubborn in its anomalies, be more than a mystery? Might it be a fragmentary clue? The idea began as whispers among theorists who noticed something curious. The timing. Interstellar objects arrive unbound by the sun's gravity, their paths shaped not just by local forces, but by influences acting across the entire galaxy. If the universe is expanding and accelerating, then every wanderer that crosses our skies carries within it the imprint of that Acceleration. Could the subtle deviations in 3I atlas's trajectory be less about outgassing or surface geometry, and more about the influence of the invisible energy field that pervades all of space? Some dared to imagine that these visitors might act as natural test particles, not just moving through gravity wells of stars, but drifting along the unseen currents of dark energy itself. If true, then studying their paths could offer something no telescope could otherwise provide, a direct measurement of the invisible hand that drives the cosmos apart. Perhaps 3I Atlas's subtle, stubborn deviations were not anomalies at all, but the signature of cosmic acceleration, written into the course of a single shard, drifting silently across the solar system. But that thought carried a deeper unease. Dark energy is not gentle. If it is the force driving the universe's expansion, then it is also the force that will dictate its fate. Whether a big freeze, where galaxies vanish into eternal silence, or a big rip, where space itself is torn apart. To imagine 3I Atlas as a messenger of this force was to confront a sobering truth. Even stones from the stars may carry tidings of our ultimate end. Philosophically, the link transformed Atlas from a local puzzle into a cosmic symbol. It was no longer just a fragment from another star, but a reminder that every corner of the universe is subject to forces beyond our comprehension. Its silence, its strangeness, its refusal to conform, all could be read as the quiet voice of dark energy itself, whispering that the cosmos is not stable, not safe, but driven by something unseen. Within NASA, such discussions were held carefully. No one could claim proof. The deviations could still be explained by surface irregularities, but the connection was irresistible. Interstellar visitors might be the only physical samples of a universe shaped by dark energy, drifting into our solar system uninvited, both visitor and teacher, carrying in their paths the handwriting of the cosmos. And so, 3I Atlas became entangled with the greatest mystery of all. If dark energy is the hand that writes the fate of galaxies, then perhaps these wanderers are its pen strokes, tiny marks that reveal the grand design. The fear, then, was not only of what 3I Atlas was, but of what it represented, that every visitor from the stars is also a reminder that the universe itself is racing toward a destiny no civilization can escape. Months of scrutiny followed. NASA turned not only its telescopes toward Atlas, but also its ears, the great radio observatories, Arecibo. Before its collapse, the Green Bank telescope and the Allen array were enlisted to listen. If the object were artificial, if it were whispering across the void, the instruments would hear. But what they heard was silence. Deep, unbroken silence. At first, that silence was reassuring. A rock does not speak. A comet does not broadcast. An absence of signal meant natural origin. But those who knew the history of SETI, the search for extraterrestrial intelligence, knew that silence is not always simple. It can mean disinterest, it can mean camouflage, it can mean communication in a language or frequency humanity cannot yet perceive. Silence itself can be strategic. The telescopes strained across every wavelength, searching for pulses, narrow band tones, or bursts of structured noise. Nothing came. The absence of a signal was catalogued, filed, and officially declared consistent with a natural object. And yet, the unease lingered. Oumuamua had been silent too. If both objects were probes, their muteness could reflect not an absence of intelligence, but the patience of it. Perhaps the true purpose of such visitors is not to announce themselves, but simply to observe. The fear deepened when scientists recalled Stephen Hawking's warnings that an advanced civilization might never wish to reveal itself. That contact, if it came, might not come on human terms. A silent probe fits that mold. It needs no dialogue. Its presence alone is the message, and perhaps the message is not even meant for us, but for others of its kind, scattered across the galaxy. Within SETI circles, the silence carried philosophical weight. In a universe governed only by natural processes, silence is expected. But in a universe alive with intelligence, silence can be far more unsettling. It may mean we are surrounded by watchers who have no interest in speaking. It may mean we are not yet worth the reply. Or it may mean that we are deaf to the true language of the stars. To the public, silence is easy to dismiss. Nothing to see, nothing to hear. But for those attuned to the strangeness of 3i Atlas, the absence of a voice was louder than any broadcast. For in silence lies ambiguity, and in ambiguity lies fear. If Atlas were natural, its silence meant nothing. If it were artificial, its silence meant intent. Philosophically, silence is as heavy as speech. Humanity often mistakes quiet for absence, but in the cosmos, quiet may be the loudest answer of all. 3. I Atlas drifted past Earth, mute, neither confirming nor denying the suspicions it awakened, and that muteness became its legacy. Was it the hush of stone or the hush of strategy? The search for signals became less about detection and more about reflection. To strain ears toward the sky and hear nothing is to be reminded that the cosmos does not answer easily. Sometimes it does not answer at all, but silence too is a message. And in the case of 3i Atlas, the message was clear enough. Not every visitor comes to speak, and if silence was unsettling, vision offered no comfort. For NASA and its global partners, hope rested on the new generation of eyes. Instruments built to see the sky with unprecedented clarity. The James Webb Space Telescope, fresh into operation, turned its golden mirrors to peer into the infrared, hunting for faint heat signatures invisible to older eyes. The soon-to-be completed Vera Rubin Observatory promised to catch every transient wanderer crossing the night sky. Together, they formed humanity's sharpest gaze into the cosmos, and yet, even under these eyes, 3i Atlas refused to resolve into certainty. James Webb captured its fading infrared glow, but the challenge was immense. The object was small, faint, already receding into the dark. Spectra were gathered, but they spoke in riddles. Hints of carbon compounds, ambiguous traces, no thermal plumes, no glow, no obvious jets. Only the faint warmth of reflected sunlight from a surface that would not confess its secrets. Vera Rubin was hailed as the sentinel of the future. The great surveyor that would, scientists promised, transform the hunt for interstellar objects. Where Pan-STARRS and Atlas had found only 3 in a decade, Rubin was expected to find dozens, perhaps hundreds. If 3i Atlas was strange, it would not stand alone. Patterns would emerge. Context would come. Yet the promise was always about tomorrow, never today. For 3i Atlas, the window of observation was closing. Each passing hour pushed it farther from our reach. And in that narrowing window, humanity's awe was sharpened. So too was its fear. We had built machines that could peer across billions of light years, capturing the birth of galaxies in Webb's golden gaze. Yet here was a single shard drifting through our own backyard, and it refused to reveal its truth. The irony cut deep. The most distant horizons opened easily, but the nearest visitor mocked every attempt to understand. Inside NASA, the tone turned cautious. Public statements spoke of data limits, the need for patience, the promise of future instruments, but behind closed doors there was frustration. If Webb and Rubin, the sharpest eyes in history, could not unmask this mystery, what hope was there of confronting a visitor even stranger? If even our best vision failed, perhaps these objects were meant to evade us, and so the situation became symbolic. Humanity had always believed that better instruments would yield deeper truth. But 3i Atlas exposed a flaw in that faith. Some mysteries are not hidden by distance or technology. They are hidden by their nature. To see is not always to understand. And so Webb's golden mirrors, Rubin's wide-field surveys, humanity's proudest achievements, became reminders of our limits. Perhaps no telescope will ever see clearly enough. Perhaps some questions are meant to remain unanswered, drifting away with the object itself, vanishing into darkness where no lens can follow. 3i Atlas reminded us of astronomy's greatest frustration. We can observe, but we cannot pursue. The visitor hurtled through the solar system, uncatchable, destined to vanish. And so, NASA's focus shifted from data collection to dreams of pursuit. engineers and scientists began drafting bold proposals, missions to intercept the next interstellar wanderer before it escaped. If these visitors were becoming a pattern and not an anomaly, humanity could no longer stand idle. Concept studies emerged. Could a spacecraft be launched in time to chase Atlas? The math was cruel. Its lead was too great, its speed too high. Catching it would require propulsion systems that existed only in theoretical papers. The dream of pursuit was impossible this time, but it ignited something bigger. Preparation for the next one. Ideas for an interstellar probe began to take shape. A spacecraft stationed in the outer solar system, waiting for the next wanderer to appear. Rapid response thrusters could pivot it into an intercept course, gathering close-range data before the opportunity slipped away. Other proposals imagined launch-on-alert missions, spacecraft built in advance, ready to fire the moment a new trajectory was detected. The logistics were daunting, but the urgency was undeniable. The discussions inevitably turned to propulsion. Chemical rockets were simply not enough. Nuclear thermal engines, solar sails, ion thrusters, even ambitious fusion drives powered by beamed energy, all were considered, because only such speeds could ever make an interception possible. In this way, 3I Atlas became more than a puzzle. It became a challenge, daring humanity to grow, to innovate, to stretch its reach beyond what was comfortable. The fear running through these conversations was practical as well as philosophical. Each interstellar visitor came and went in a flash. Oumuamua, Borisov, Atlas, arriving unannounced, then fading into the void, leaving behind only fragments of data. Without pursuit, without interception, the truth would remain forever out of reach. And that meant living with ambiguity, a kind of cosmic blindness. How many relics, probes or strange shards had already slipped past us? Unstudied? How many more would we lose to the dark if we did nothing? For NASA's engineers, the pursuit proposals became more than plans, they became a mirror of ambition. To chase an interstellar object was to face the limits of human capability. To admit that exploration requires more than curiosity. It requires risk, invention, resolve. Philosophically, this was a threshold moment. To pursue Atlas, or its successors, would be to step into a new era of exploration. No longer limited to our solar system, humanity would begin to reach into the galaxy, one visitor at a time. But with ambition came dread. For if one of these objects were truly artificial, interception would no longer be simple observation. It would be contact. And contact, as Hawking warned, may not be safe. The very act of pursuit could transform humanity from observer to participant, in a drama it does not yet understand. This was the weight of 3I Atlas. It forced the question, would we meet the next visitor only with our eyes, or with outstretched hands? And in that question lay the essence of fear. To chase is to risk, but to stand still is to accept ignorance. The choice is not between danger and safety, but between danger and silence. And so, beyond the data and the equations, a deeper question stirred. What if 3I Atlas is not just a fragment of the universe, but a reflection of us? Every observation, every debate became a mirror, asking humanity to decide what kind of species it wants to be. If the visitor were a probe, a creation of unknown design, what responsibility would fall upon us, the ones who found it first? The question was unsettling. To ignore the possibility of intelligence was to risk blindness. To declare it too soon was to risk hysteria. Between those extremes lay a narrow path, a responsibility to seek truth with humility, to interpret without projecting too much of ourselves onto the silence. The fear was never just that Atlas might be alien, but that we might fail to respond wisely if it were. Ethical dilemmas multiplied. If such a visitor is a relic of another civilization, even one long dead, is it not a heritage object? Would capturing it be an act of science or sacrilege? To study such an object would be to become the archaeologists of the galaxy, inheritors of a past that does not belong to us. And with that inheritance comes duty, respect, humility. The silence of Atlas did not erase that responsibility. Even if it were natural, the questions remained. Should we treat such wanderers as curiosities, or as reminders that Earth is no fortress, but a crossroads, and to live at a crossroads requires awareness, readiness, humility? NASA's fear was not only about impact risks or alien technology, but that humanity might fail to recognize its place in the larger story unfolding around it. Philosophically, the reflection deepened, cutting into existential territory. If 3I Atlas was a natural object, it carried a sobering truth that planetary systems can shatter, worlds can be scattered, and survival is never eternal. But if it was artificial, its message was even more haunting. That intelligence, too, leaves wreckage behind, and one day we may cast our own fragments into the future skies. Either way, the lesson is the same. We must face impermanence with clear eyes. The thought lingered. One day, Earth will send its own emissaries into the galaxy. Probes, spacecraft, even the ruined remains of satellites will drift through interstellar space. They will outlive us, our nations, our civilizations, even the planet that launched them. When some distant intelligence encounters them, will they be seen as relics of wonder or warnings of arrogance? Our response to 3I Atlas may be a preview of how others will one day respond to our legacy. And that sense of responsibility carried a shadow of fear. NASA's scientists felt its weight. They knew their interpretations would guide public opinion, influence policy, and shape how humanity sees itself. To dismiss the object too quickly was to risk burying a revelation. To exaggerate, it was to risk distorting the truth. Their job was not just to measure, but to act as guardians of perspective. And so, 3I Atlas became more than a visitor. It became a mirror. It asked the question, how do we meet the unknown? With fear, with arrogance, or with humility and reverence? The answer to that question was not just scientific, it was moral. Perhaps this is why NASA feared 3I Atlas most. It was never only about what the object was. It was about what we might become in the process of facing it. So the work continued. Telescopes turned back toward the heavens, scanning for any lingering traces of the intruder. Faint clouds of dust, microscopic grains, or subtle chemical fingerprints left behind in its wake. 3I Atlas had already vanished into the dark, but its data still existed, waiting to be reinterpreted. This was not glamorous work. It was slow, patient science, the kind that takes years rather than weeks. But it was the only path forward. Hubble had given its glimpses. Now the James Webb Space Telescope, with its extraordinary infrared sensitivity, was ready to capture the next event. On Earth, Pan-STARRS kept watch. Soon, the Vera C. Rubin Observatory would join the effort, scanning the sky every night, ensuring no new visitor would go unseen. Behind the scenes, simulations grew ever more complex. Supercomputers mapped the paths of rogue objects across the galaxy, trying to predict where the next might appear. What if a future object contained engineered metals? What spectral signatures would reveal it? Could subtle patterns in its heat or polarization betray an artificial design? These were speculative scenarios, but in exploring them, NASA turned fear into preparation. Instruments were calibrated with unprecedented precision so that even the smallest clue could be caught. The difference between a comet and a probe revealed in a single spectral line. Spectroscopy became a language to be mastered, a way to read the hidden stories written in light, and collaboration expanded worldwide. NASA partnered with the European Southern Observatory, JAXA, and private observatories, weaving a planet-wide network of vigilance. No one nation could claim ownership of such mysteries. They belonged to humanity. Other missions contributed too. OSIRIS-REx, which once sampled an asteroid, offered insights into how surfaces weather in space, creating a baseline for what is natural, so that the truly alien could stand out. Soon, newer missions would carry even more sensitive instruments, building a vast catalogue of cosmic signatures. This is how science advances, slowly, methodically, sometimes imperfectly, but with relentless persistence. NASA could not demand certainty, but it could push back the darkness of ignorance. And so, its fear of 3I Atlas was met not with despair, but with determination, the commitment to be ready next time. When the next interstellar wanderer crosses into the solar system, the instruments will be waiting, sharper, faster, hungrier for truth.